to understand the crown of thorns, we need to understand a little bit about its life cycle. It's like a lot of marine organisms. It has an adult benthic stage where you see that large starfish, and then the planktonic stage of the larvae. So there are sort of two competing hypotheses of why crown of thorns outbreaks occur. One being that it's to do with nutrient limitation of that larval phase, and the other that it's sort of overfishing or removal of predators of the adults. And prevailing theory really that most people seem to be falling into really is this one of larval starvation. That's led to the general observation that these high islands tend to be places where we would worry about this crown of thorns starfish. And a lot of the work that the Living Oceans Foundation did, we started there in 2002. We had the outbreak in Marea, which was noted by Kale et al. And sort of followed for 10 years or so, 2002 to 2011, 12. So we're kind of coming in on the back end there. But what we see is that we had an outbreak occurring here in Marea or Tahiti. And generally it seems like it may well have moved up this direction through the Society Islands, and then our work suggests it's actually made it out to some of these atolls. So these are no longer high islands, but we want to look and see if this is actually whether or not we can use nutrients to explain the distribution of these crown of thorns outbreaks. So here's some useful work that was produced in Australia recently, and this is work by Katherine Fabricius. And she noted through her experimental work a very good threshold of 0.25 milligrams per meter cubed of chlorophyll. I should say that coral reefs tend to be nutrient poor environments. So, that might not seem like a lot of chlorophyll to people around here, but, that's certainly a big increase in chlorophyll for a reef. And that we get differential outbreaks of these crown of thorns starfish depending on that. Sort of using that threshold, I've done some mapping here. So this is a 10-year remote sense data set of chlorophyll taken from the MODIS satellite for the French Polynesia region. And one of the interesting things we see is that actually these high islands don't tend to get chlorophyll values that reach that level that you would expect to get outbreaks. In fact, actually, if we go to the atolls, we tend to get much higher levels of this chlorophyll, particularly within the lagoons. So that isn't perhaps suggesting that it's sort of almost speaking against that high island story, but nonetheless our observations still suggest that we do see these outbreaks in those high islands. So then one of the other things that I'd like to look at here, and I'm going to sort of very much just sort of speed over this, is whether or not ocean current patterns at least explain this distribution of outbreaks. Because if the ocean currents if the outbreaks of the crown of thorns are following what the ocean currents suggest they should, that at least helps us with our understanding that it may be starting in these major high islands. So again, we're starting down here in Tahiti and Marea and moving up through the Society Islands. And crucially, we're not moving out to the Tuamotu archipelago or the Gambier group, where we also did some work. So here we're using a different type of spatial data. So this is HICOM global ocean circulation data to try and look at how these larvae may be moving within and between these different atolls and island groups. So I don't really have a lot of time to go into the detail here, but essentially the model supports a general westward and northward movement from the south of the Society Islands. So it does support the distribution of that crown of thorns outbreak, and it also does support the notion that if it starts there, it doesn't move to the Tuamotus. Particles move from the Tuamotus towards the Society, but not vice versa. And here, if we zoom in on one of these on Marea, where we have the best data, we see that yes, we do have situations where very periodically we get these nutrient spikes that go above that threshold. And if we look at where they are, they're very much located quite close to these major watersheds feeding in around Marea. If we come onto the I've lost my southwest coast, we've got very typical oceanographic conditions, but on that northern coast we get these occasional spikes. So just to conclude, what do we see here? Well, we're saying that coral reefs, like marine systems anywhere, really face a range of threats, and that these are operating across different spatial and temporal scales. And I tried to use that crown of thorns example to indicate that. I'd suggest that we can use remote sensing as well as a variety of different mapping and modelling technologies to understand the distribution of resources and vulnerability of these systems to threats at a number of different scales. But I should also say probably assets at a number of different scales. Regarding the crown of thorns, high islands don't necessarily relate to nutrients. So it's not that, in my view, that characteristic is perhaps a little overly simplistic. But really what we're seeing is this sort of ephemeral delivery of nutrients. So it's not just the magnitude, but there's something going on there which is sort of to do with that ephemeral delivery. And the ocean current patterns corroborate a lot of what we're seeing here. And sort of final note, I guess, is that watershed management, if we could target those particular watersheds which perhaps are feeding this problem, actually that has the capacity to help out across a very large area of reefs spread across thousands of kilometres of ocean. So when we think about sort of marine seascapes, we need to think, yes, locally, but it's quite a broad scope, I would suggest. So that sort of takes me to the end.
In the 1990s, there used to be an